Okay. At t seconds after liftoff, the height of a rocket is 3t squared feet. How fast is the rocket climbing after 10 seconds? So height, if the height of a rocket is telling me its position. It's saying, well, you know, you start down here on the ground and then you're this high after t seconds, and then you're this high after another second, right? That's telling me your position. But I want to know, how fast is the rocket climbing after 10 seconds? What is your rate of change at exactly t equals 10? Everybody follow what we're doing right here? Is the problem clear? The difference between position and rate of change. My position right now is I'm in Los Angeles. And if I get in my car and I drive for 5 hours, I can be in San Francisco, right? So my position has changed from 0 to 400 miles, right? But if I want to know, well, how fast was I going at any particular time? If I have a function, I can tell you the formula for figuring out how fast I was going, my rate of change. So let's see if we can get an answer here. What's the formula that I'm going to use to describe, to calculate the rate of change? Clark, can you help me?
Okay.
Good.
Let me see. Honestly, I'm not sure. I'm trying to look through my notes.
Yeah. You want another minute to look, or or should we phone a friend here?
We should phone a friend here.
Okay, listen carefully then. Isabella A, can you tell me, what is the formula we're going to use to find the rate of change?
Would it be f of t plus h minus f of t over h?
Minus f of t over h. You are almost there. You're missing one thing.
I'm not sure what I'm missing.
You are missing, we want the limit as h approaches 0. Do you remember?
Yeah, I remember.
Is that clear, or is it not? You want me to explain it again a little bit?
No, you're good.
I'm good. Am I good with everybody here? Okay. This gives us the rate of change at an instant. Now, if I just said, what's the average rate of change? Well, then Isabella was right. The average rate of change I can find just by doing this, right? But if I want it at an instant, then I have to do it with limit approaching h approaching 0. So in this particular case, what is our f of t? Okay, so I'm trying to find f of t. Alex, can you help me? What is f of t?
I always get confused at this. Is it wait. I'm a little confused.
Well, look at the problem. F of t, they give it to us. They're telling us the function. They're telling us how far, they're telling us the height of the rocket at any particular time. So what is f of t? It's right there in the problem.
Oh, 3t squared.
Yeah, f of t is 3t squared. That's telling us, well, if I want to know the height of the rocket at any particular point in time, that is 3t squared. Okay, so I got this part of my formula. I'm doing pretty good. I want to get this part. I want to get what is f of t plus h. Okay, so f of t plus h. Maria, what is f of t plus h?
Would it be 10 plus 3t squared?
You know, I can understand why you would say that because we're looking at t equals 10 seconds, right?
Yes.
But before we can put this into our calculations, we have to find the formula to find the instantaneous rate of change. So we're using this right here. This is going to give us a formula to find the rate of change at any particular second. So we're not quite ready to insert t. We're not quite ready to insert 10 seconds. Am I making sense at all? Maybe just a tiny bit. Okay, so I'm going to ask you a question, Maria. If I wanted to find f of 7, how would I do that? Here's f of t. How do I find f of 7?
Would I just plug it into
Yeah,
that?
so it'd be 3 times 7 squared. Are you okay with that?
Yes.
Which would be 147. Aren't you impressed that I did that right there so quickly in my head? I'm impressed. You know, is that right? Yeah, I think that's right. I think it's right because 7 squared is 49.
Mhm.
And 3 times 150, 3 times 50 would be 150, but it's only times, oh no, it's 148. Sorry, I made a mistake. But ignore what I'm saying here. Okay, so we got f of 7. Maria, I want f of p. How would I do that?
So you just plug it in?
So 3 times p squared, yeah?
Yes.
I don't want either of those. I want f of t plus h. So what is it?
Would it be just, so in the place of t, I would put in t plus h. So would it be 3t plus h squared?
That's exactly what it would be. Yeah, right. It's very easy to do it with 7 and p, but something about having a more complicated argument of the function tends to throw everybody off. So that's what it would be. It would be 3t plus h squared. Is there a question about that? Everybody's okay. All you people with your cameras off, you're okay? Give me a thumbs up if you're okay. Yeah, Mia, tell me.
So for the 10 second, for t equals 10 seconds, we would leave that to the end.
Yep.
Okay.
Yep. First, we need to find the formula for finding the rate of change. And then we can actually plug the number in. Okay. So so now I'm going to use this right here. And I'm going to use what I found, f of t and f of t plus h. So I'm going to find the limit as h approaches 0 of f of t plus h, which is this right here, 3 times t plus h squared. Everybody clear on what I just did there? I just took f of t plus h and I stuck it into my formula right here. minus, well, f of t, which is just 3t squared. I just took f of t, which is 3t squared, and I stuck it into that part there. And this is divided by h. Now, I'm trying to get to a point where I can do substitution. Can I do substitution yet? Let's ask Alex again. Can I do substitution yet?
No,
Why not? I want to.
because if you plug in 0, the denominator would be 0.
Damn, I think you're right. Can't do it. Can't substitute yet. So I'm going to do some more algebra here. I have the limit as h approaches 0. I haven't been able to get rid of that yet. So I have 3 times, well, I'm going to FOIL this out. And that'll become t squared plus 2th plus h squared minus 3t squared. All I did was FOIL this part out, and it's all divided by h. So now I can substitute. Is that right, Clark? I can substitute now?
No,
No. Why not? You're ruining my day. Why not?
because the denominator is still h, so you need to like cancel, right?
I can't cancel it yet though, right?
Or like continue foiling, not foiling it out, but like expanding or like limiting. I don't know. You need to keep working on the program.
I
on the
need to keep
problem.
working on the problem, right? I need to keep working on the problem. That's absolutely right. Because if I substitute 0 for h, I'm going to be dividing by 0. And we all know it's all fun and games until somebody divides by 0. So we're not going to divide by 0 yet. All right, so I have the limit as h approaches 0. So I'm gonna distribute this 3, okay? So I get 3t squared plus 6th plus 3h squared. And now I'm gonna go minus 3t squared. And that's all over h. Okay, so I still got this h in the denominator, which is preventing me from substituting. But Maria, what can I do now to kind of move this problem along?
Well, the 3t squared and the negative 3t squared, you can like take those out.
Let's get rid of those.
And then you're left with 6th plus 3h squared over h.
Keep going, tell me, keep going, you're on a roll here.
Do we have to FOIL it? I'm not sure.
Nah, we don't want to FOIL it yet. We're still trying to get rid of this h in the denominator. There's something we can do though. Limit as h approaches 0. Okay, Mia, what can I do?
You factor out a 3h.
Okay, let's factor out a 3h from the top here. 3h, and that leaves me with 2t plus h, right? Over h. Everybody see what we did? Okay, and now I can cancel out these h's. Oh, that's nice. So now I have the limit as h approaches 0 of 3 times 2t plus h. So, magic bowl. I'm just calling the same people over. Magic bowl has not been functioning properly lately. I don't know, how can that possibly be? Okay, Maria, again, I pulled it out a minute ago. I pulled it out again. Obviously, the heavens are determining that they want me to call you. Yeah, can I do substitution now? Finally, can I finally do substitution now?
Yes.
Why?
Um,
Why can I do it now and I couldn't do it before?
I don't know, but I just I just know that we can substitute now.
Okay,
I'm not sure
okay,
why,
but
but-
I want to know why. Maria, why couldn't I do it? Why couldn't I do it up here? Why couldn't I do it at that? Why couldn't I substitute 0 for h right up here?
Well, we still have that denominator, so
We still have the denominator. So why can I do it now?
there's no denominator.
I got no denominator. I can use 0 now. I'm not going to be dividing by 0. So now when I substitute, I'm getting rid of the limit. So I get to my formula being 3 times 2t plus 0. So really that I don't care about the 0, that's equal to 6t. Six T is the, let me okay, I want to make this very clear here. Let's try this here. This right here is what we started with. This limit as h approaches 0 of 3t plus h squared minus 3t squared over h. And we just did that step by step by step, just working some algebra until we got down to 6t. Well, you know what, ladies, these two things are equal, believe it or not. 6t is equal to this whole big thing. We just did some algebra here to simplify it. So if this limit as h approaches 0 gives us our instantaneous, let's write in English. Instantaneous rate of change. If this formula gives us our instantaneous rate of change, and I just did some algebra, I ended up with this. This is going to give me my instantaneous rate of change. I don't need all this nonsense. I just need this. So at t equals 10 seconds, how fast is this rocket going? At t equals 10 seconds, how fast is this rocket going? Brooklyn, how fast is the rocket going at t equals 10 seconds?
Is it just 6 times 10? So
That's exactly what it is. It's 6 times 10. It's going 60, I don't know, what are our units? Let's check our units. 60 feet per second. 60 feet per second. That is how fast the rocket is going at t equals 10 seconds. Is there a question? We're kind of happy with this so far. So far? Okay, well, let's just push it a little bit further, okay? How high above the ground is the rocket after 10 seconds? How high above the ground is the rocket after 10 seconds? I want you to think about that for a second. Let's go back to the problem here. How high off the ground is the rocket after 10 seconds? Jordan, how high off the ground is the rocket after 10 seconds?
not sure.
Okay, so read the problem. Read it out loud.
At t seconds after liftoff, the height of the rocket is 3t squared feet. How
Stop. No, stop right there. Okay, now, at 10 seconds, how do I figure out how high the rocket is off the ground?
you plug in 10 into the into 3t squared.
There you go. This
Yeah.
is my position function, right? So if I want to know how high the rocket is after 10 seconds, I don't need to go down here where Brooklyn took us, that it's going 60 feet per second. That's how fast it's going after 10 seconds. But if I want to know how high it is off the ground, I'm just going to come back to my original function here, and I'm going to go, oh, well, that's 3 times 10 squared. Well, that's 300 feet. So the rocket is 300 feet off the ground at t equals 10 seconds. Make sense? Yes, no, yes. Oh, Jordan gives me a thumbs up. Everybody's giving me a thumbs up. Okay. All right. So now let's ask a different question. Okay. Here's the rocket. Here's the rocket starting here at 0 seconds. And then in 10 seconds, here's the rocket. It's up here, and we just determined, Jordan helped us determine it's 300 feet high, right? And this was 10 seconds. What's the average speed of the rocket over those 10 seconds? What's the average speed of the rocket over those 10 seconds? Crystal.
Would you would you plug in like both variables into that equation, the limit equation?
No, you're making it much harder than you need to. But Crystal, we're going to ask another question here, okay? I'm going on a tangent right now. Here I am in Los Angeles, and I want to go to San Francisco, and this is 400 miles, okay? And it takes me 10 hours. How fast was I going on average?
4 miles per hour.
Not 4. You're missing a decimal there.
40 miles per hour.
Yeah, I took 400 miles. That's the distance that I went, right? And I divided it by how many hours it took me. So I was going 40 miles per hour on average, right?
Yeah.
Okay, now the rocket is 300 feet high, and it took 10 seconds to get there. How fast? What's the average speed of the rocket over those 10 seconds?
So would you do 300 divided by 6?
6? Where'd 6 come from?
60.
No.
Wait, where? Well, you need 300, right?
I need the 300. Yeah, I need the 300. So we're moving in the right direction. That's good.
And then, oh, is it 10?
Yeah, because it took me 10 seconds, right?
Yeah.
So my average speed was 30 feet per second. My average speed was a lot slower than my instantaneous speed. That's because the rocket's speeding up. I mean, the rocket better speed up, otherwise it's going to fall back to the Earth. It's never going to make it to the space station. Yeah, does that make sense? Yeah, we doing okay with this? Okay. So I am going to stop recording.